Hello, great people. Today, let's look at again. Let's continue with our trigonometric series. Here we have another problem. We are asked to prove that sine of 2x minus cos of 2x minus 1 divided by sine of x minus cos of x is equal to cos x. And then it says, hence, determine the value of x if this whole expression is equal to 1. Let's start from the beginning. We have double angle identities here. Whenever you have this type of problem, start plugging in the double angle identities. What do? Here we replace sine of 2x with 2 sine x cos x. Please, if you're not very careful or you don't know what to replace with, please check the formula sheet. It will be there. Pick up the right identities, because picking up the wrong one can destroy everything. Here, cos of 2 theta can be replaced with 2 cos squared x minus 1, and then we have our last minus 1. Remember, we are asked to prove that the right hand side is equivalent to what we have on the left hand side. So we cannot use both sides to work. You simplify one side or simplify both sides to make sure that they are equal. So we cannot bring all of them over. Please, that's the rule. And then we have sine x minus cos of x. Now let's go forward and simplify. This is going to be 2 sine x cos of x minus 2 cos squared x. This becomes plus 1 minus 1. So this plus 1 minus 1 takes each other away. And then we will have the same denominator. Now, what next? We will go ahead and factorize the numerator, because there's no other way. We need something that we can do to simplify this, and factorization is always a sure way to simplify complex expressions. So, check for common factor here. We have 2 on either side of the minus sign, and we have cos x. So this will be, we have 2 cos x as our common factor. 2 cos x into the first section, 2 sin x cos x, we have sin x left. Minus 2 cos x into this is 2 cos x cos x, so we are left with cos x. Divided by sin x minus cos x. What do? We have similar things. Remember, why can't we cancel out here? We can cancel out across minus and plus. When expressions are separated by minus and plus, they form a unit, and they can only be cancelled out together, not by parts. So, and that is what we have established here. We can cancel them out together. This takes away this. And then what do we have left? We have 2 cos x left, which is what we also have on the right hand side. So we can just say left hand side is equivalent to right hand side. That is what they want us to prove, that what we have on the left hand side can be simplified to become what we have on the right hand side. And that is what we have proven. Now let's go to the second part. The second part, they're asking us, hence means in mathematics, the word hence means continue from where you have started. Based on what you have done, can you use it to verify that so and so goes on that way? Now, hence, determine the values of x if this is happening. Now, what do we do? Since this whole thing, since we have established that this whole thing is equivalent to 2 cos x, that is the purpose of the hence. We don't need to start all over again. We will replace it with 2 cos x. We have established that. Now, replacing it with 2 cos x, we go ahead and solve for x. Cos of x is 1 over 2. Here we have value of values. So it may be more than 1. Typically, someone will just go cos second function of this is of half is going to give us 60 degrees. And it doesn't stop here since they are demanding for values. Yes, x will give us 60 degrees. If cos is positive, we have to consider all the quadrants where we have cos as positive. Cos is positive on the first quadrant and also on the third quadrant. So this is not just the value that this is going to yield. It has to yield other values. So for quadrant 1, we will have that our x will be, it is the acute reference angle plus k360, k being an element of integer. That is for quadrant 1. Now we go again for quadrant 4. X can be 360 minus the acute reference angle. We call this the reference angle because it's acute. So 360 minus this is 300 plus k360. K being elements of integer. This boils down also for cases where we are given a restriction. So for this is spoken, we can get multiple values of x. If we make k1, we can get 420. If we make k2, we can get, so if k, it depends on the revolving. Let's restrict this and use it as an example. If they say that x will be element of negative 180 to 360. Let's place our own restriction to it. If these will be the values of x that are needed for this expression. Now this is what we're going to have. First things first, we make k negative 2, that's 720, so high it cannot fit into the restriction given or the range of values given. If we make this a negative, it becomes 60 minus 360, which is minus 300. It cannot fit in there as well. Now, for values of x, we are looking at, if we make k 0, we will have 60 degrees. If we make k1, we have 60 plus 360, which is 420 out of the range. Remember, k represents the number of revolutions, or the number of times it is revolving. Now, let's go to this one. If we make k negative 1, we have 300 minus 360, which is negative 60, is the value that is accepted in the range of values. If we make it negative 2, we have 720, way out of the range of values. If we make k a 0, we have 300. 300 is within the range because this range is from negative 180 until 360 with those final values excluded. If we make k1, it becomes way above the range. So with this, we can see that these are the range of values that we can get. That is why they asked the value of values of x in that expression. So always check out for something, double angles, replace them proof, and then check out the range of values given to you. Be very careful when you are using your quadrants. That will determine if your value is going to be positive or negative. Positive or negative will also help you pick the quadrants you are going to work with. Remember what we did here, this is active, that's why we use here. For quadrant 4, remember it is supposed to be 360 minus the reference angle. And that is how we have 300, 360 minus 60. So if it was here, we have 180 minus or 90 plus. If it was on the third quadrant, we have 180 plus or 270 minus. So this is the approach for this type of problem. If you have any question, please stop in. And please remember to share, like and share, and also share your comments, ask your questions, and do have a blessed day.